Hi everyone, today we're going to look at the number system and go beyond the discussion of real numbers. Let's begin by understanding the fact that there is a lot of different types of numbers, infinitely many. Because of this, mathematicians needed a way to classify numbers, to group them, and tell them apart from each other. We're going to begin by taking a look at the different subgroups of numbers that exist. Let's begin with natural numbers. Natural numbers are simply whole numbers that are greater than 0. These numbers are 1, 2, 3, 4, or any number that you can physically count. Natural numbers do not include negative values. Whole numbers are all natural numbers including 0. These numbers are 0, 1, 2, 3, 4, and so forth. In regards to integers, integers are whole numbers, but now we're going to include both negative and positive along with 0. So numbers such as -3, -2, -1, 0, 1, 2, 3 are all considered integers. Rational numbers are numbers that can be written as a fraction, where both the numerator and denominator are integers. This means that the top and the bottom of the fraction are whole numbers. Examples of these would be 1/3 and 23/7. As a reminder, if you look at the root word of rational, you'll see it says ratio. A ratio is simply a comparison of two numbers that can be written as a fraction. Irrational numbers, on the other end, are numbers that can be not written as a fraction. Examples of these would be pi and the square root of 2. If we try to write these numbers as decimal, they go on forever with no reoccurring digits. And then finally, we have real numbers. A real number is any number that you've ever come across in mathematics up until this point, which would include all rational and irrational numbers. In your study of mathematics, you may have noticed that some of the quadratic equations do not have any real number solutions. For example, why will you never be able to find a real number solution to the equation x squared equals -1? At this point, I want you to pause this video and think to yourself as to why there is no real number solution to this equation. All right, hopefully you realize that with this particular equation, x squared equals -1, it's saying find a value of x that when I multiply it by itself is going to give me an answer of -1. However, this should draw a red flag because you know that any number times itself is always going to be a positive. Consider this example. If x was 1, 1 squared would simply mean 1 times 1. Well, we know that's going to give me an answer of +1. Now, if we consider x to be -1, -1 squared is simply -1 times -1, which is again +1. There is no number that's either positive or negative that I can substitute in for x that will give me a value of -1. I will only get positive answers. Therefore, this equation has no real solutions. Now, in this next example, it asks, are you able to find a real number solution to the equation x cubed equals -27? Again, I want you to pause this video and think about whether or not there is a real solution to this. After some consideration, hopefully you realize that there is a value for x that does work. The answer is -3, and that is because when I take x cubed is simply x times x times x. So if I replace x with -3 and cube it, -3 times -3 is 9. Times it by one more -3, I get -27. So therefore, the answer to this problem is -3, which is a real number. Now, looking back at this example that we just looked at on the previous slide, x squared equals -1, although we did not have a real solution to it as mathematicians, we wanted to create a new number system that would actually allow us to solve this equation. That new number system is called a complex number system. So, looking back, solving the equation x squared equals -1 should look something like the following. Something squared equals -1. To get rid of that square, we know to undo it, the inverse operation is to take the square root of both sides. And when I take the square root of both sides, you can't forget that plus or minus sign. Because no matter what number I choose, whether it's positive or negative, when I square, it will give me the exact same answer. Therefore, the answer to this problem is x equals plus or minus the square root of -1. Now, technically, you can't solve for a square root of a negative number. Think back in the day when you take a square root of a negative number, you would always write no solution. That is because only real numbers can be multiplied by themselves to yield a positive number. This is why mathematicians created a new type of number. The opposite of real is not real, so these are called imaginary numbers. Therefore, the solutions of the equation x squared equals negative 1 we found was x equals plus or minus the square root of negative 1. Mathematicians ignore the negative value and focus on the square root of negative 1 as the fundamental number for imaginary numbers. This value is given as a special symbol I. All imaginary numbers have I as a factor. Therefore, by definition, I is equivalent to the square root of negative 1. And just to summarize, now with the complex number system that we just learned about, a complex number includes both real numbers and imaginary numbers. The real part will always go first. The imaginary part will always go second. And it takes the form of A plus BI. A for the real, BI for the imaginary. So now to look at all of our different types of numbers and kind of categorize them, if we think of complex numbers are going to include both real numbers and imaginary numbers. And as we saw at the beginning, real numbers include rational numbers, integers, whole numbers, natural numbers, and irrational numbers. With imaginary numbers, we have what's called pure imaginary numbers. These are in the form of A plus BI, where A is simply 0. When A is 0, all you have is an imaginary part. So to try to summarize this entire lesson with you guys on the number system, what I wanted you guys to get at the end of this lesson is the fact that I've introduced you this complex number system, and inside the complex number system we have a real part that consists of real numbers and an imaginary part, which consists of imaginary numbers. Inside the real numbers, we learn that they include rational numbers, integers, whole numbers, and natural numbers, as well as irrational numbers. Inside imaginary numbers that include both real and an imaginary part, we also have what's called pure imaginary numbers, one in which there is no real number. That's why it says A equals 0, but we have just an imaginary part with the letter I.